our project titled Making Eco-Friendly Bricks Using Natural Resources and Study Its Strength. A brick is building material used to make walls, pavement and elements in construction. Traditionally, brick is composing of clay, cement and sand. Making brick takes many resources from the land, causes environmental impact. The heating process releases more carbon emission, which causes air pollution. Therefore, using natural resources as building material and carried out experiments to compare their strength.
Waste material from plants known as natural resources can be used to make brick as a substitute for sand from earth. Different types of natural resources produce brick with different strength. The aim of this project is to investigate the relationship between types of natural resources and strength of the brick. To study the effectiveness of natural resources as sand replacement materials in brick. The brick made from all palm waste has the highest strength compared to the brick made from other natural resources. Apparatus and materials: measuring cylinder, weighing scale, brick making mold, plastic container, plastic bag, beaker, cement, trowel.
Materials: coconut fiber, sugarcane waste, bamboo, banana fiber, durian skin, all palm waste, cement, sand, water. Variables: manipulated variable, types of natural resources. Responding variable, the strength of brick. Constant variable, the amount of cement, the volume of water.
Ash preparation methods. The sugarcane bagasse was collected from night market. The sugarcane bagasse was dried in hot sun for 7 days to remove the moisture. The sugarcane bagasse then burned to get their ash. The ash was sieved with 5 to 10 micron sieve to separate unburned particles from ash. The unburned particles burned and blended using dry blender to get their ash. The fine was ready to mix with cement to build the brick. Step 1 to 6 repeated for other natural resources such as oil palm, banana, durian, bamboo, and coconut.
Preparation methods: 1200 gram of cement measured using kitchen scale and poured into a plastic basin. 700 gram of bamboo ash measured using kitchen scale and added into the cement. 250 ml of water measured using measuring cylinder and poured into the mixture. The mixture was mixed well for 5 minutes to get homogeneous mixture. The mixture was poured into a mold with the dimensions which is coated with plastic sheet in order to remove easily from mold when it dried. The mixture was compacted using a scraper. The brick was dried under the sun for 7 days. Then the mold was turned upside down and loosened the strings to remove the bricks. The brick was ready. Step A to H repeated for 5 other natural resources. Bricks testing methods. 3 tests were conducted for these bricks. 3 tests as below. Water absorption test. After curing periods of 7 days, the water absorption test was conducted. In this test, the brick was weighed using scale, then it was immersed in water at room temperature for 12 hours. Compression test. Compression tests were carried out in 2 methods. A test was designed to test brick as below. Compression test in school. PVC pipes were fixed into 6 feet height. A weight of 300 grams tied into a string and passed through a pulley. A brick was placed at the bottom of PVC pipe and the weight was dropped to hit the brick. The impact on the brick was recorded. The same method repeated for other bricks. Compression test using compression machine to obtain the compressive strength of the bricks. The compression test was carried out using compression machine in Masa University, Janjaram, Banting. First, the brick specimens were placed on the top of the steel plate. Then the vertical loads were applied to the upper surface of the specimen. During the test, the brick specimen compressed until failure occurred in the bricks. The failure load of the specimen was recorded and the compressive strength of each specimen was calculated in terms of MPa.
Discussion and documentation.
Density. The average densities of bricks from each type are shown in the table above. It can be seen that EFB bricks has the highest density compared to other types of natural resources bricks. Banana bricks have the lowest density due to finest ash. Compressive strength. The compressive strength of the bricks are presented in figure above. The EFB bricks has slightly less compressive strength to control brick but the highest compressive strength among other resources. EFB, bamboo, sugarcane, maize and coconut fiber have similar compressive strength than other. Durian brick has the lowest compressive strength.
Water absorption. The rate of water absorption for banana bricks is the highest among other naturals. Based on these findings, banana ash are able to fill the space which leads to the water absorption of the brick.
Cost of bricks. The calculation for cost of brick is based on raw material such as cement and sand. When sand is replaced by these natural resources such as banana, coconut, sugarcane, oil palm, durian, and bamboo, it can be a significant cost of reduction. For example, the cost of contour brick is Rm 60 cent, while EFB brick costs only Rm 48 cent. The lower cost creates commercial viability in moving towards the use of natural resources. As a replacement for sand, it provides impetus towards cleaner production in the construction industry.
Conclusion. As a conclusion, the properties of brick in which sand is replaced by natural resources ash has been studied in these experiments. The finding shows the opportunity for environmentally friendly method of managing waste products. The EFP brick has the highest strength compared to other natural resources. Therefore, the hypothesis is accepted.
Safety precaution taken in order to ensure everybody is safe while working with cement and ash.
Mask prevent from dust. Glove to keep our hands clean.
Apron or old clothes to ensure our clothes or uniform clean while doing experiments.
Sieve. The same sieve must be used to sieve the ash in order to maintain the fineness of ash.
Water absorption test. For water absorption test, the brick should not keep a long air for too long.
Acknowledgement. Project coordinators and officers of National SFYC 2018 organizing team.
Mr. S. Madhyalagan, Headmaster of SJK Tamil Puchong.
Science teacher of SJK Tamil Puchong.
Parents and people of SJK Tamil Puchong.
Dr. Jagadish Kannadasan from YTL Seman Sungai Besi. Masa University Saujana Putra Janjarom.